All right. We will start today by reviewing some of the stuff we learned in Chapter 20. Then we'll learn some new stuff, and then we'll review Chapter 19. I think I released Chapter 20 this morning. I know I went to it. I can't remember if I actually pushed the button to release it. But I feel like I did. So Chapter 20 should be released on sapling. There's only like 6 or 7 problems on there, so that's not too bad. And then probably on Wednesday I'll release 21. So this one, Chapter 20, will be due, let's say Friday at midnight. And then 21 will have to be due Sunday at midnight, only because grades are due Monday after your exam. So Friday and Sunday will be your last homeworks. Okay, so we learned carboxylic acids. The first thing we did was naming, so let's do a couple of those. Let's see. How would you name that? So we have 1, 2, 3, 4, 5, 6. Hexanoic. And why does it end in oic acid? Yeah, because of the carboxylic acid. And then how do we name this part right here? Not 3, but 4. 1, 2, 3, 4. Right, this one's always carbon 1. So 4-methyl hexanoic acid. What about this one? How many carbons? 5, so that's pentanoic. And then how'd you say you named that part there? Amino. And what number is that on? 4. So 1, 2, 3, 4. 4-amino pentanoic acid. What is this called? Benzoic acid. Okay. Then we also looked at the structure. So if we just look at the general structure, where does a nucleophile like to attack? The carbonyl carbon right here. Why there? Yeah, we have 2 electronegative atoms here, which causes this carbon to be partial positive. What? So a nucleophile, let's say like NH3, I don't know, is always attacking with electrons. What's the charge of an electron? Negative. So these negative electrons are attracted to that partial positive carbon. Does this have hydrogen bonding? Yes. So does that increase or decrease the boiling point? Increase. Are these acidic? Yes. It has that hydrogen there, and then once it loses that hydrogen, it has resonance. Or resonance will not stabilize this, but stabilize, let's try it out, the product. So base, B for base. What does the base do? Takes the hydrogen off. Okay, so when it reacts, you see here I have OH and I have O minus. So this product is stabilized because I can move these electrons around. Anyway, so we'll call it product resonance. Okay, then we also looked at putting like a chlorine on there. A chlorine on a carboxylic acid, does that increase the pH or decrease the pH? Decreases it. It makes it more acidic. Do you remember why? Yeah, electronegative atom. It weakens this bond right here because it's a magnet pulling all of the electron density towards it. So since this bond is being pulled towards chlorine, it's weaker. So and the more chlorines you have and the closer they are, the more severe the effect. Okay, we looked, whenever a carboxylic acid is in this form, do you remember what it's called? Yeah, the carboxylate. So it's the carboxylate. That's what I'm saying, why. Then we looked at some old ways we've done in the past to make carboxylic acids. So we did this. Okay, how many hidden hydrogens are here? 2. Is this a strong or a weak oxidizing agent? So this one's strong. So how many times will it oxidize? 2 times? So anytime you can oxidize 2 times, what does it become? Carboxylic acid. So where the alcohol was, you see right here, that's where the carbonyl is, and where you attach the OH. So it always turns a primary alcohol to a carboxylic acid. So we have KMNO4. What does that do? Yeah, so it cleaves the double bond and caps it with oxygen. And then what does it do to the hydrogen? Oxidizes the hydrogen and turns it into the alcohol. So I cleave. It does nothing to the carbon groups, but that hydrogen coming off, it'll turn into the OH. So in this case, I made carboxylic acid and a ketone. So what was necessary to make the carboxylic acid? What did I need in here? The hydrogen. So you can only make a carboxylic acid if that hydrogen is coming off of it. What about this one? Yeah, it'll make 2 carboxylic acids. So we cleave it right down the middle, and I have 3 bonds there. 2 of them will become the carbonyl, and the third one will become the OH. So I have C double bond O OH plus C double bond O OH with a methyl. Yeah, you can also use ozone. I came in a 4, and ozone will do the same thing there. So you see here we have CH, and you see CH. It's just capped with a carboxylic acid. And here I have CH3, and then right here, CH3. They're capped with a carboxylic acid. Okay, I believe those are the 3 we learned last week. There is one more old one, and it was this here. This is from your benzene chapter, which I believe is chapter 17. So if we look at KMNO4 above, what does it do? It's an oxidizing agent, and it also cleaves, right? And it's going to do the same thing here. What does it turn this carbon group into? What does it turn carbon groups into above? The carboxylic acid. So what it does, no matter how long or how big your carbon chain is, it cleaves it off, or it cleaves all but one carbon off, and turns it into a carboxylic acid. So no matter what, it could be 50 carbons long. You put in KMNO4, and you're going to get a carboxylic acid coming off of benzene. So it turns any carbon group, any carbon chain, into a carboxylic acid. I also want to remind you before I forget, your presentations for Wiki are this week during the lab time. And since there's not physics lab, you can come either Tuesday or Thursday. Okay? I don't care which day. I assume I'll probably get a lot of people on Thursday. But either day is fine with me. We have plenty of time blocked off to do it then. And I think it's going to work out fine where we do the final at 9 a.m. on Monday. But instead of doing it in here, because I believe they're going to have A and P, we could do it in the other. Is there anybody in A&P? Okay. Is anybody else? Okay. If you do have a problem with A&P, let me know. But what we'll do is we'll have it in 217, just the room next door. Okay. Now here's a new reaction to do a carboxylic acid. It's new, but I think it'll make sense, hopefully. So if we have something like this, all right, what is this right here? A Grignard. And Grignard always adds a carbon group. Now CO2 is, carbon dioxide. But you see the final product here, I have that carbon group, right? And then you see C, it looks like O2, with the hydrogen, but you see the carbon with 2 oxygens. That comes from the CO2. And so CO2 kind of looks like this. And do you see that kind of looks like a carbonyl? So what charge is this carbon here from the Grignard? Negative charge. And where do you think it makes a bond? This carbon right here. And then one of the electrons will go up. Do you think it matters which one? No. And what do you think the final step will be? Yeah, the oxygen. We'll grab that hydrogen there, neutralizing it to become the carboxylic acid. So not too bad. So anytime you see Grignard with CO2, basically where the Grignard was, that's where you put your carboxylic acid. So if we have okay, how many carbons in this chain here? 5. 1, 2, 3, 4, 5. So we'll draw the 5. 1, 2, 3, 4, 5. And then CO2, what will that put at the end? Specifically, what functional group? Carboxylic acid. So I have my 5 carbons there. Now I'm going to add my C double bond O OH. So I have now 6 carbons. But 5 of them are from the carbon chain. 1 of them is from the CO2. Another new one, or the last new one. Okay, so let's look at this. What is this here? Yeah, it's just an alkyl halide. Okay? And do you see here, this carbon actually has a lone pair and a negative charge. So which one's my nucleophile, which one's my electrophile? Yeah, this is the nucleophile. It's always the one that wants to make a bond. So it's always like the negative charged one. Or if there's not a negative charge, then it has a lot of lone pairs on it at least. Okay, and where will it want to make a bond? Yeah, where the CH2 is. And why there? Yeah, it gives this carbon a partial positive, and this is also a good leaving group. So this is going to attack. Bromine will just leave. So the result is bromine leaving. Now attached to that CH2, I have C, and then I'm going to put the triple bond in there so you can see it, triple bond N. Yeah, so now I have this nitrile. It's kind of similar to what we did in chapter 18. Let me go ahead and put the answer on here so you can kind of see what we're getting to. Let's see, 1, 2, 3. This is the carboxylic acid chapter. Okay, so you said oxygen from the water is going to bond to that carbon, and then what will happen here? Because this carbon already has how many bonds to it? 4, so one of them has to leave. So it's leaving, yeah, grab a hydrogen. Do you see, and let me put, it was NH with acid, yeah, NH4. Okay, so do you see that this nitrogen is no longer on the main product, right? And now that I put the side product, you see it has a lot of hydrogens? So we can see that this is going to keep grabbing hydrogens. So CH2, C, and how many bonds now here? It was a triple bond. Now it's a double bond. Then I have N, H, and then the water on here. Okay, so do you see? I now have a double bond there. Nitrogen grabbed a hydrogen. So double bond. Nitrogen grabbed a hydrogen. And then over here, water attacked this carbon and is added on there. Okay, what do you think happens now? Yeah, oxygen can push its electrons down, which will cause us to grab another hydrogen there. Yeah, sorry. Here you go. Okay, so I still have CH2, C. Now how many bonds to nitrogen? 1. And how many hydrogens does it have on it? 2, no. Okay, so we're getting closer. We need to kick this off, right? And then how many, if we go to our product here, how many oxygens on it? 2. Notice I put excess water, so I'm going to put a lot of water in there. So where do you think our other oxygen comes from? Another water molecule. So I'm just going to draw it right here. Water. Make a bond right there. Cause those electrons to go up there. Okay, so I'll give you a second to write that down. Make sure you have it. All right, what is our leaving group on this? The NH2 will leave. Okay? Now, out of these, I have, because one of these will become the double bond O. Which one is more negative, I guess? It's the OH, okay, because that one's positive. So this one will push its electrons down, which will cause NH2 to leave. And as it leaves, it'll grab one of the hydrogens off the water there. And it's going to grab it off that one because this is the one with the positive charge. So what does this leave as right here? NH3? I always do this. I draw really large over here, and then end up doing really small over here. Okay. So we have, let's look at what we just did. This OH pulled its electrons down. So you see now it's a double bond there. NH2 left, and as it left, it grabbed the hydrogen. So it left as NH3. Now this water here is just OH. What's our final step? We're almost there. Do you see we have a little chain, CH2, C double bond O, OH, but we need to take off this hydrogen right here, and that's it. So just take off that hydrogen, and that leaves us NH4. Okay, that's the mechanism, but let me show you how to quickly predict the product, because I'm sure when you do the predict the product, you don't want to have to go through the whole entire mechanism, because it's quite long. So what you do here, if you see this, you're always going to have an alkyl halide. And then something like this. So you have your nitrile, and then acid and water. Okay, everything happens where this bromine is. Okay, C triple bond N. Do you see that it's going to put an extra carbon there? So I draw my carbon group, and I'm going to put my carbon there, and that's from the nitrile. And then after it reacts, that N, is it there at the end? No, what does it turn into? Carboxylic acid. So where the bromine is, that's where you put your new carbon. And by the end, that carbon is the carboxylic acid. So pretty much bromine is replaced by a C double bond O OH. So it's replaced by a full carboxylic acid. Yes? Yes, it'll always be just a carbon to a nitrogen. No, since it should be a negative charge, because that's the only way this will go all the way to the carboxylic acid. Because if you recall in chapter 18, this one's a little bit different. Well, yeah, carbon chain, and then you also have Grignard. Okay, so let me show you the difference between these. This one, first, notice that this is not a Grignard. This one is. Okay? This one, is there a carbon chain coming off the CN? No, but you see there is one here. And I put a triple bond stuff. Okay, so those are the two differences. This one has a Grignard with a nitrile with a carbon chain. This one is not a Grignard, no carbon chain. So when you do this one, the final product, yeah, it's a ketone. So this is the carbon chain that was on the CN. This is the new carbon chain you added, and then the water makes a carbonyl. But do you see, okay, so two waters attacked in the above one, right? We have one water forms the carbonyl, one forms the OH, okay? And we have one carbon group. But we already have, on this one we have two carbon groups, so we don't have another position for the other water. So only one water attacks because we have two carbon groups already there, and notice here we have one. Because off a carbonyl, how many groups can we add? 1, 2. Okay? In this case, my two are carbon. In this case, one's a carbon, one's the OH from the water. So that's the difference. So again, if you want to know when do I make the ketone, when do I make the carboxylic acid, this one's an alkyl halide with C triple bond N with a negative charge. This one is Grignard with a nitrile with a carbon chain. So those are two things. So Grignard and then carbon chain equal ketone, and then alkyl halide, no carbon chain, equals carboxylic acid. Okay, so just so you know the difference between those, because they are very, very similar, and I don't want you to get those mixed up. Okay, so those are all the ways to make a carboxylic acid. They're the old ways, and then the two new ways. That would be with the nitrile, the nitrile with a carbon group, and then Grignard with the CO2. Those are the two new ways to make carboxylic acid. The reactions of carboxylic acid aren't too bad. So let's look at least a couple of those, and then we'll take a break and then start reviewing for the exam. So here's carboxylic acid. Okay, so with the carboxylic acid, what do you think the leaving group is? Water. So OH as water. And in this case, whatever our nucleophile is, it could be whatever. I'll show you different nucleophiles. This will just come in and replace it. And that's pretty much most of the reactions of carboxylic acid. Water leaving group, nucleophile replaces it. So if we look at the first one, it's an esterification. So what do you think we're going to make? An ester. So the first thing I'm going to do is predict the product. Okay? So what's my leaving group? Water. And what will replace it? OCH3. From right here. Okay, let's look at this mechanism. I have an acid in there, so what will it do first? Oxygen will grab that hydrogen. And because they do this on sapling, let me actually make, instead of putting H+, let me actually make that hydrochloric acid. And I'm doing it, I'm actually choosing an acid only because sapling chose this one, so I'm going to make sure you see it. Normally I just put H+, meaning really any acid will do. Okay, what do you think happens next? Here, yeah, this is going to attack here. This alcohol will attack right here and cause those electrons to go up. Well, not yet. This one will actually form a neutral intermediate. So what's the only thing that's charged in here? OCH3. So if we're going to make a neutral intermediate, what will happen? Yeah, the chlorine from over here will remove this hydrogen here. So it's a single bond. Okay, so this, there's at least two problems on sapling that go over this neutral intermediate. So neutral intermediate is whenever you have your nucleophile on there, your leaving group is still on there, and your carbonyl oxygen is still on there. So everything's on there, nothing's left yet, and it's neutral. Okay, so that's what the neutral species is. All right, now what do you think happens? Let's look at our final product here. Yeah, I'm going to pick the top one. Push the electrons down. And what will leave? Yeah, OH. And where will it grab its hydrogen? Here. So if we see here, make sure we know what happens. These electrons push down. And this is that's a single bond, by the way. These electrons push down to make the double bond, okay? OH leaves, and what does it grab? Hydrogen. So I have OH, I grab a hydrogen, that becomes H2O. Hydrogen leaves its electrons on oxygen to put an extra lone pair on there. And that's my final product. Okay, so let's do a predict the product. we'll redo all of these mechanisms on Wednesday that we learned today. We'll do them again. So what is my leaving group? Water. And what will it replace with? Yeah. O carbon chain. 1, 2, 3 carbons long. Oxygen, 1, 2, 3. So it's always attached at the oxygen there, okay? Because we're making an ester. Remember, ester is C double bond O, O carbon. You'll want to make sure you have these functional groups down pretty well, so let's just review these. Because these are important for biochemistry. I think that's all of them. Okay, what is this? Aldehyde? Here? Ketone? This one? Ester? OH? Maybe carboxylic acid? What did you say this one was? Amide? What about this one? RO, yeah, ether. Alcohol. And amine. Notice that amine and amide kind of sound the same, right? And they're very similar. The difference between an amine and an amide is an amide is attached to a carbonyl. So it's a carbonyl with an amine. That's an amide. And then the other one would be ester and ether. So an ester is an ether with a carbonyl. All right, and then let's look at what would you predict here? Yeah, an NH2. So my leaving group is water, and I'm going to replace it in this case with NH2. Think of it this way. This needs an extra hydrogen, right, to leave as water. You're going to get a hydrogen from right there. And so I just turned a carboxylic acid into what? An amide. So if we looked at this mechanism, which will be pretty much the same mechanism we just did, but let's review it again. What happens first? So we have HCl in our first step. Grab a hydrogen. and then step 2, we have NH3. What are we going to do with that? Attack the carbonyl. Make the electrons go up. Now, just like before, we're going to make our neutral species. So what happens here? Chlorine will take off a hydrogen from the nitrogen to make it neutral. And then what about here? When the OHs will do what? Push its electrons down, which will cause the other alcohol to leave and grab a hydrogen. Alright, so let's stop there and take a break. And then when we get back, we'll review. Okay, so remember the exam is tomorrow. Hopefully that doesn't surprise anybody. And that's only over 18 and 19. And remember, all of the amino acids are on there. Or I'm not going to put all of them on there, but they're all fair game, okay? We reviewed 18 on Thursday. So if you need to relook at that, that should be Thursday's vodcast. Yes. Yeah. Okay, 1 minute. Oh, yes. Go on then. What is your question?
If we use a protecting group,
Mm-hmm.
ketone and aldehyde on there, will it attack the aldehyde first or the ketone first?
The aldehyde will always go first. Aldehyde is most reactive, so it'll always react first. No matter what, that's for protecting groups, but any reaction, aldehyde will always be attacked first. Okay, other things that are due this week, so we all know, would be Chapter 20 homework, and I'm going to set that due Friday. I don't know what the due date says right now. I'll check it. It might not. It might say something like August 30th or something. I don't know. 17th? Okay, yeah. So it's not due the 17th, but it's going to be due Friday at midnight, and I'll go on there to edit that. It says the 17th because I had no idea when I was going to make it due at that time. And then Chapter 21 will be due Sunday at midnight. Your final is on Monday. What I'm going to do for the final is, let's see, how should I do that? Let's do all the homeworks. So the homeworks will be your exam review for the final, and I will pull questions from the homework questions. Okay? So that will be your pool of questions there. So at least you have an idea what I'm going to ask. Okay? And that will be set up just like last semester, where the majority of it will be multiple choice, and then I might have 4 or 5 problems that I work out. Now the workout will be from the new stuff. Okay? So chapters 20 and 21, that was, I could put a mechanism or something like that on there. Okay? But everything else, all the cumulative part of it, that'll be multiple choice. Okay? Let's see. There's a discussion, and that cannot be due Monday at midnight because I have to have grades in before then. So all of your stuff that's usually due Monday at midnight will be due Sunday at midnight. And it's only because I have to have the grades in. Like literally the day I give the final, they make you turn the grades in that day. And what I'll do is I'll try to have those grades posted pretty quick. And then I'll probably be here for another hour or two, so if you need to come and protest your grade or something like that. I'll send out an email when the final grades are up so you could look at that. And then I'll be here for another hour or two if you need to see me. And then I'll probably be gone after that, but if you need, like if you weren't able to come Monday and you need to meet another day, I mean, as long as you email me and tell me, I can be up here. Okay, but if nobody emails me, I will not be up here. So I had the discussion, we had sapling, and then your presentations are due either Tuesday or Thursday, whichever day you want to do it. And it's the same presentations we had before. So basically, get your wiki page and present it to us. Okay, using your all your references, each week when we had something, I think we had like introduction, just to make sure you kind of introduce the topic, go over the results, apply it to class, apply it to chiropractic, all that kind of stuff. Just put that all together and present it to us. Okay? All right, so that's everything that's due. And then this exam is tomorrow. So let's start reviewing Chapter 19. And again, Chapter 18 review was on Thursday. So if you need to relook at that, that's on Thursday's vodcast. I believe the second half of class. I don't know why I flipped over Okay, so the first thing let's look at is naming. So chapter 19 is an amine. These are amines. Okay, so I want you to name this and then also tell me if this amine is primary, secondary, tertiary, or quaternary. Okay, what is the longest continuous carbon chain here? 4. 1, 2, 3, 4. How do we name 4? Bute. And then this, how will it end? Amine. So anytime we have an amine as the main functional group, it'll end in amine. So butanamine. And then this is a methyl. And then how did you say? You put N-methyl. And what does N stand for? That it's coming off the nitrogen. So N-methyl butanamine. And then what did we say what this was? Primary, secondary? Secondary. And why secondary? 2 carbon groups coming off of there. So it makes that a secondary amine. How would you name this one? So do you remember what like that is called? Aniline? Yeah. So the base name is aniline. Hmm? Well, you could do M, but you have to say what the M-methyl. So you could say M-methyl. And what does M stand for? Meta. Or I could have done, let me put methyl, aniline. Yeah, I could have put 3-methyl. So aniline, that means NH2 is your priority number 1. So I go 1, 2, 3. So I could put 3-methyl aniline. Or you could say that's in position meta. Either one is correct. It just depends on which one you prefer, really. Okay, do amines have hydrogen bonding? Yes, as long as it has that hydrogen. So if I had this one here, does that one have hydrogen bonding? No. Most amines have hydrogen bonding. The exception is obviously they don't have that hydrogen there. Between let's say NH3 and H2O. Okay, so just comparing oxygen to nitrogen, which one would have a stronger hydrogen bond? Which one's more electronegative? Oxygen. So alcohols will always have a higher boiling point than amines because they have stronger hydrogen bonds. So I could have these two here. Do you see they look very similar? It's just this one has the amine at the end, this one has the alcohol. This one will have the higher boiling point because it has the stronger hydrogen bonds because oxygen's more electronegative. amine can act as a base or a nucleophile. So a base means that it'll do what? Take off a hydrogen. And then nucleophile means it will attack, like a carbon, make a bond to something. In organic chemistry, it's usually a carbon group. Okay, and then in this chapter, we looked at basicity. Okay, what makes it a stronger base or weaker base? So we had these. All right, out of these, which one is the stronger base? The one on the right, because there's no resonance there at all. There's no double bonds to move around. So remember, resonance stabilizes something. So if you want something to be very basic, that means it's going to be very reactive. So this one is the most basic. It's not stabilized by resonance at all. All right, what about between these two here? Which one's more basic? The middle. Because this one already has a a double bond there to resonate around. And this one, does it? No, so you'd have to use its lone pair to resonate. So this one needs a lone pair to resonate around. And then this one has a double bond, so you don't have to use the lone pair. So remember, a lone pair grabs a hydrogen. This one, you don't need to use it. So it's a little bit more basic. So I'm just going to put basic. This one has to be used. So I'm just going to call it least basic if we want. So this one's the most, the middle, the least. Okay, then we looked at some reactions. The first one we looked at was a Hoffman. Okay, what happened in the first step? Put as many CH3 groups as I can. And what's the magic number? What's the max? Not 3, but 4. 4 is the max. So how many carbon groups does it have right now? 2. So I'm going to add 2 more. When I do that, I have a nitrogen with a positive charge, which is what? What will it do? It'll leave. Okay, I have hydroxide. What does it do? Not as alcohol, but it's going to act as a base. What does a base do? Takes off a hydrogen. Okay, so we need to figure out where is this hydrogen taken off. Okay, so this nitrogen with a positive charge, think of it as a giant bromine or something. Okay, does it matter? I'm going to look at these. can I make a double bond with a methyl? No, because it takes 2 carbons to make a double bond, right? So I can't make a double bond, between there. So I'm going to come down here. Nitrogen's connected right here. And then, so that's where it's connected. That's where it'll leave. And then you make the double bond 1 away from that. So either here or here. Now, does this go to the most substituted or the least substituted? The least substituted. Because this, you see this is really bulky up here. It's large, right? So your base is going to have to take away from the least bulky side. Okay? So it can basically fit in there. So we take off a hydrogen that's hidden here. And this is an elimination. So elimination, what do we always form? Double bond. So leave its electrons there. Cause that nitrogen group to leave. So the Hofmann reaction, anytime you see methyl iodide with a base, that's your Hofmann. And what it does, first step is make nitrogen into a good leaving group. So you add all your carbons. Second step is to take off the hydrogen to form the double bond. And then we always form the double bond on the least substituted side because your leaving group is so large. Okay, so let's do one more of these. Okay, so this one just showed me the very final product. So work on that a minute, and then we'll check it. Okay, how many carbon groups would we add? 3. It's already connected to 1, so you got 3 more. Okay, and this is where the nitrogen's connected. Okay, so where would you form the double bond? To the right. You see this side has an extra branch there, so put X and X. That side has an extra branch, so that's pretty substitute over there. This is the least substituted. There's no branch. So this side has the double bond, and this would be N CH3 3, because you said you're going to add 3 of them, 3 methyls. This would be the product that I'm looking for here. So you see here, this leaves. Do you see when that leaves? Do you see that that you get this, basically? Okay, so then this brings us into a cope rearrangement. No. So the cope rearrangement looks kind of similar. So now you have peroxide. What does peroxide do in this case? Adds an O minus onto this nitrogen. So it oxidizes it. So I have a negative and positive in that structure. What is it called when I have a negative and a positive in the same molecule? You could do it that way. It's polar, but how many charges do we have? 2, so it's like dipolar. Or you could call it zwitterionic. Either, they mean the same thing, dipolar or zwitterionic. I don't know in biochemistry which one he tends to use, but just know they're both the same. Okay, so now what I've done here, do you see now I have a nitrogen with a positive charge, just like with the Hoffman we just did. And this oxygen up here with a negative charge is a built-in base. Okay, so you see over here I had to put in OH minus, but here I already have my O minus built in. So then I just needed to see where do I pull that hydrogen off to do the elimination. So my nitrogen is connected here, so I can go to the left side or the right side. Well, does this look bulky? Yes. So it goes to the right. Both of them, both the Hoffman and the cope, will go to the least substituted. So I get my elimination there, and then my nitrogen, I can do it like this. You get this. This is a oxamine. But this is the main product I'm looking for right here. So a cope is just like a Hoffman. Okay? This one I have to add my carbon groups to make nitrogen positive, and then I put in a base. This one I oxidize the nitrogen to build in a base. But they do the same thing. Once you make nitrogen into a good leaving group, whatever your base is, takes off a hydrogen from the least substituted side, making a double bond. So the cope is just a fancy Hoffman. Okay, then we also looked at this. So this would be kind of like for a synthesis. All right, this is a little bit more difficult than it looks. So if you look from the starting material to the product here, I'm adding a carbonyl. Okay, but what steps do I have to take to actually be able to do that? Yeah, so I need to put 2 equivalents of my carbonyl. Why do I do that? Yeah, so just 1 equivalence is going to go here. an amine is a way better nucleophile than benzene. Remember, benzene, you have to have, it's just not very reactive. I mean, it can react. We obviously have a whole chapter of reactions. But an amine is way more reactive than benzene. Benzene is pretty stable because of the resonance. So if I only added one of these groups, it would go to the nitrogen. Okay? But I'm adding two. So one will go to the nitrogen, and the other will go on benzene. So that's why you have to add two, because this will happen. If I don't add two, I will only get this right here with the carbonyl, or actually this would be an amide. Now how do I take this off? Just H3O plus. All right, and then the last type of reactions we did here. Would be the reductive amination. Okay? These are the ones they do in Breaking Bad. I was actually watching it last night, and they were talking about methylamine. So if let's do the one with methylamine. So methyl is what? CH3. And then NH2. So there's your methyl amine. Now all of these are pretty much the same thing, the mechanism here. So I have this, okay, my first step, what will happen in the mechanism? I have the hydrogen, so let's grab that first. Now what will attack it? What will make a bond there? Yeah, there's nitrogen, the NH2 here. What happens here? Say that again? Yeah, alcohol will grab one of the hydrogens from the amine. And then, is this water a good leaving group? What will force it to leave? Lone pair of nitrogen will come down, force that to leave. And basically, the water is going to come back around and take off this hydrogen to neutralize that. But this reaction is called reductive amination. So reductive, what does that mean? I'm going to reduce it. Say, do you see I have a lithium aluminum hydride in there? What is that a source of? It's a reducing agent, so what will attack here? H minus, right? Hydride. So this lithium hydride is my H minus. And where will it make a bond? The carbon where the nitrogen is. This will come back up, end up grabbing a H plus. Here. And if I'll draw, you don't have to draw this hydrogen coming down here, but I'll draw it. That's from your hydride. And that's your final product. And we need to get, so that's the mechanism, but we need to get good at just predicting the product on those two. So for the mechanisms, just so you know, on the exam, I'll either ask here to here, and I would say there's a good chance I could ask that one, or just the reducing part, which would be just here to here. This mechanism from here to here is in Chapter 18 and in Chapter 19, so that's a good way for me to use one mechanism for both chapters. Okay, so let's predict a product from these. The mechanism, no matter how many carbon groups coming off, the mechanism is the same. Okay, because let me come back here. Did I do anything with this methyl group? No, it's just there. So if I had 2 methyl groups coming off of there, do you think it matters? No, the mechanism is the same. So if I have this. Now we need to get fast at predicting this. In the end, do I have that oxygen on there anymore? No. What does it replace with? The nitrogen. And then after I reduce it, is that nitrogen as a double bond or a single bond? Single bond. So I'll have single bond nitrogen with its methyl groups. Now, if I didn't reduce it, so let's say step 2 wasn't there, then that would have been a double bond nitrogen. But with the reducing, oh, there's an L there. With the reducing agent, it becomes a single bond. So in Chapter 18, we have basically like this reaction. This reaction is where we have the double bond in. So that's basically just step 1. And then in this chapter, we learned that you could also add a new step, step 2, to make that double bond into a single bond. So the difference is, does it have lithium aluminum hydride in there or not? If it does, then that'll be a single bond in. If it's not in there, then it's a double bond in. Okay? That's the difference between the two. We also did like this. So this one's a little bit different because I have a leaving group. What would my leaving group be? Chlorine, yeah, which would leave as HCl if you want. And then what will replace it? NH2. And that's for the first step. With the amine, when you have, normally it would reduce an alcohol, but when you have an amine on there, it actually will just get rid of it. It acts just like zinc hydrochloric acid, and that's with the amine. So that's step 2. I believe that's all the reactions we learned for chapter 19. So I'd say the big mechanism, there's only one really that I would focus on for chapter 19, would be the one we just did with the reductive amination. Okay? So let's practice some synthesis. I'm going to mix kind of 18 and 19 both in there. Okay, so look at these 3 here. I'm very proud of these 3 I just made up. Okay, for time's sake, we will do them together. What do we have here? So look what you started with and what you end up with. Okay? I'm starting with a ketone. And what do I end up with? Yeah, so an amine, right? So if I end up with an amine, I can pretty much guarantee you that's going to be some reaction in chapter 19. Okay? Because that's the amine chapter. Now here, I have a nitrogen group on here, and how is it bonded? With a single bond, right? And I have this carbon group, I have 2 methyls. So do you see that these 2 methyls could be the same 2 methyls, hopefully, maybe? So what do I do here? What's my first step? H plus with, well, no, like, what do I put in there? Not the mechanism. Yeah. NH2, CH2, CH3. So this, do you see N, CH2, CH3 is the same as this, N, CH2, CH3. And nitrogen, kind of carbon, its kind of lucky number is 4. Nitrogen, it's 3. So you just put a number of hydrogens there that you need to neutralize it. Okay. So that would put this nitrogen group on there. But how do I make this into a single bond? Yeah, lithium, aluminum hydride. And that's the full synthesis there. So I add my nitrogen group on there, which originally that would make it a double bond. But then I reduce that double bond with lithium aluminum hydride. All right, let's look at this one here. This one's a bit crazy, right? Now I have a double bond group here with these carbon groups coming off. And I start off with a alcohol there. Wittig. So anytime in this exam, you all of a sudden end up with a double bond, like an alkene, and you added carbon groups. So do you see originally here, I have 1, 2, 3 carbons. But now I have 1, 2, 3, 4, 5, 6. So I have more carbon groups plus a double bond. So that would be Wittig, because Wittig adds carbon groups and makes a double bond. Okay? But what do I react a Wittig with? It's not an alcohol. Well, that's the, yeah, well, I could do this here. So I could put the pH3 first, and then what's my carbon group I'm adding? It's, yeah, it's that top part right there coming off. It's basically the new carbon part of it. So this is 1, 2, 3, 4. Oops. I added too many carbons. Here. So it's the new carbon group, like coming off. So this should be 1, 2, 3, 1, 2, 3, and then, so that Y part is the new part. All right, so that would be the Wittig. But if you go back, the Wittig always reacts with a carbonyl. Okay? How can I turn alcohol into a carbonyl? Oxidize it, because right, I need to make more bonds to oxygen to make a carbonyl. Now, how far do I want to oxidize this? 1 time. So what do I use? PCC. So when I oxidize that 1 time, I can do the Wittig to put the carbon group on there. So the carbon group just replaces the oxygen. All right, now let's look at this last one. Here I have an acid chloride. Then over here, and it has 1, 2 carbons. This one has 1, 2, 3, 4 carbons. So I need to add carbons for 1, and then get rid of the carbonyl. How can I add a carbon group? So is chlorine a good leaving group? Yeah. And then how can I add a carbon group onto there? Not the Grignard, but the copper lithium. Okay, and how many carbons do I need to add to it? 2, right? So it has 1, 2 here. There's 4 there, so we need 2 more. 1, 2. Now that would make this. So 1, 2, 3, 4. That's good. 1, 2, 3, 4. So my carbon chain is correct. But how do I get rid of a carbonyl? Reduce, but specifically? Not that one, but zinc hydrochloric acid. Or you could have used the Wolff-Kitchener, which is the HNNH with hydroxide. Either one of those would have been correct. So definitely synthesis is harder because you have to apply all your knowledge together. Okay, so don't forget to look at your amino acids. And the review. So review from today and then also from Thursday if you need to pull that back up. All right, so good luck. I'm going to write the exam now. I wanted to see what I focused on in the review before I wrote it.